All right, good evening. We'll get started for the night's presentation. I'm Devin Nowlin. I'm the Museum Project Director. And tonight I'll be the MC as we'll get into the program as quickly as possible, and I'll just provide some brief introductions and talk about the format for the evening. This is the fourth community forum in a series of programs aimed to share developments about the building project with Williams College, Williamstown, and the Berkshire community. And we've previously presented on the architectural design, the landscape design, the building and site sustainability features in previous talks, and those are recorded and available on YouTube and on the building project's website. And we are also recording the program tonight. This evening we have fortunate timing for a talk on the museum's mass timber structure as framed by this year's campus theme, the Year of the Log. We'll share how the design and engineering innovations of the new WICMA design are expressed through the architecture to embody a warm, welcoming museum environment and reflect evolving relationships between nature, learning, and the community. We'll start with some framings for especially members new to our audience, with Pam Franks, class of 1956 director of WICMA, sharing the teaching museum's mission and our museum design. Then Scott Henderson, senior project manager with the college's planning, design, and construction office, will situate the project within the Williams College context for mass timber and for sustainability. Our special guest tonight, we have Kevin Lamb, Associate Principal of SOLID Objectives IDENBURG LIU, or as many of us know them, SOIL, who will delve deeper into how the design of the mass timber on this project evolved conceptually and practically, with insights into some of the building's most unique features. And then Danielle Gray, who is the Senior Virtual Design and Construction Manager with Consigli Construction, will describe modeling and manufacturing methods that are used on the project, and will share plans on how the mass timber will be erected on the site this fall. And so those of you who are in the audience tonight will start to see trucks coming in starting in next week through the coming weeks, and you'll be in the know about what is happening on site. After about a 30 to 40 minute presentation by our speakers, we'll have a Q&A session. And we're really encouraging questions from the audience that spur conversation among the presenters tonight. So we'll have a full program with lots of opportunity for Q&A. So first off, please join me in welcoming Pam Franks.
Hi everyone, it's so good to see you all. Thank you so much for your interest in the Williams College Museum of Art, which I will refer to as WICMA, so you'll know what I'm talking about. WICMA stands for Williams College Museum of Art. Our mission and everything we do, who we are, everything we do, is about the vitality that comes with learning with art. The kinds of conversations that art can spur, the magic that happens with really close, direct access to art. Everything about this building project is about increasing the availability of the collections, a really dynamic program around what art brings to society and to life. So it's just such a privilege to actually be able to design a new building together with SOIL and the whole team around this really clear mission. The building itself is exciting for so many reasons. The location is going to be incredibly transformative for us. It's right across from the roundabout, right as you enter campus, right as you enter Williamstown. So it's going to be such a kind of strong statement for the vitality of the arts in this region. And it's going to be much more accessible, much more kind of visible, welcoming, and just really a place for all of us to come together around art. So that's super exciting. The design itself is really deliberately meant to kind of resonate with the beautiful natural surrounds and be a statement of the kind of possibilities of aesthetic experience architecturally, naturally, and of course with art. So that's super exciting. I think one of the ways that we talk about it a lot and that you can see in this rendering is that the roof line actually really echoes the mountain surrounds in a beautiful way. And I think that's going to come through in the materials tonight too. Just from a slightly different angle, the approach to the building shows how sculptural it is, and it really invites you in as you approach through this meadowed landscape up to this kind of form that changes depending on how you approach it, and really invites this very sculptural experience and sort of kinesthetic engagement with the architecture and with the art inside. And tonight's program, of course, as Devin said, is about the mass timber design and the ins and outs of constructing with mass timber. And this view of the lobby of the new WICMA really gives a sense of how integral the wood itself and the structure is going to be to the experience of the building. So it'll be warm and welcoming. Echo what Devin said, I think that's such an important part of it. It will also be really evident what the structure is, and so the building itself becomes a learning opportunity as the art is. It kind of asks you to think about how the building is constructed and made, because it is leaving much of the structure visible in the common spaces. You can also see in this view the kind of way that the ground floor is organized around the courtyard, and the light and green throughout is an animating force, and I think that's going to be really beautiful. Oh, sorry, with the materials. Thank you for that. And then finally, for my brief introduction, I just wanted to again circle back to the centrality of the teaching mission by landing on a classroom with works from the collection installed, and the idea that everything about this project is about direct access to the art, to the architecture, and to all of the learning and community that those things can foster. So I just wanted to really give a very brief overview of our sense of purpose with this project. It's a huge group project. There's many people here from the museum team tonight as well as from the project team, so take a chance to speak to everyone and learn more, but I'm super excited for Kevin and Danielle's presentations on mass timber specifically.
Hi everyone, I'm Scott Henderson. As Devin said, I work in the Planning, Design, and Construction Office. And I'm just going to go through some quick notes on sort of the decision making that led us towards mass timber construction. And I'll admit I have the least interesting slides tonight. So as Pam noted, the importance of the project reaches many levels. And of course, the art element is key among them. But also, we took it as finding this opportunity to start to shape how future generations would engage with the art, and then tie in sustainability elements, and also tie in the fact that we're extending campus with this project. So how do we bring that idea of Williams across the busy intersection, across the street? And we also took it as an opportunity to take on a responsibility that carries forth the mission of Williams, the educational mission, and then the environmental commitments tied to our sustainability goals. In this case, we're also doing an extension of a few past projects with the Living Building Challenge. In this case, it's core certification. I think we talked about that at the last forum. And then, of course, back to the sense of place. And through that process, the early conversations sort of led us to discussing around the idea of how can we express these values, what materials can we use. And through thinking about that, we explored sort of the past 10 to 12 years of sustainability throughout our projects, our capital projects, and tried to find these connections where we were integrating sustainability with the program instead of having them sort of run parallel through our projects. And a way to do that we found on this project was to really focus in on the structural components, the sort of framework of the building. And once we did that, mass timber became very prominent on the list. It became basically our focal point there. And the reason for that was sort of its alignment with both its own performance as a structural system, but also tying to our sustainability goals, and then the idea of experiencing a building and being able to interact with certain structural elements. So this combining sort of aesthetics and engineering in a way that tied, as Devin and Pam talked about, sort of the feel of the space, but also taking on the idea of carbon, embodied carbon reduction, and then just the sort of movement away from elements like steel, which have very high carbon, embodied carbon. And then the value-based decision-making too, tying to that, the idea of the stewardship, again, tied to the embodied carbon, but also demonstrating and becoming a learning tool on campus about decision-making on our projects. These aren't just building buildings for the sake of expanding campus. It's really about the ideas that tie into it. Tying to human experience, again, the sort of feel of a wood timber building compared to, say, traditional methods used to date elsewhere on campus. And then the regional connection, too. We talk a lot about sort of the New England architecture, the barn, the frame, back to heavy timber. This is sort of the evolution of that process. And while it's not within, say, a 300-mile radius, which is kind of a go-to for a lot of sustainability goals, we're just a bit further. We're about 600 miles in this case. And we've partnered with Nordic that, again, has a very strong sustainable approach that aligns with us and our projects. So at the end of the day, our goal was really to take the museum and represent something that we can demonstrate our choices in our materials, in our ideals, in the process of developing these projects. So that's sort of the backdrop to the decision-making that put us in this position. And I will gladly hand it over to Kevin and Danny to really get into the details about this. All right, thanks. Kevin.
Hi, Kevin from Soil. I'm going to be speaking a bit about the design of the building itself, but then also how mass timber is sort of incorporated in a really fundamental way. I think before proceeding, just to share that one way to think about the following slides is that rather than a sort of exterior and interior, or structure and the clothing of the exterior, or the kind of purpose-built functional spaces and the surrounding public spaces, we really want to think about the design as a single kind of unified whole, where all sort of elements are really working almost as in a single design. So it's not that these different aspects of the building are kind of separate solutions, but rather that they're tied into one single expression. I'm going to start just by situating everyone. So as Pam mentioned, we're here at the intersection of Route 7, and then you have Route 2 here. And the site, which you see in the dashed line, is it's a really excellent site, 6.75 acres. And what's, I think, really exciting is that it's also it has some of the same physical characteristics of the hills that Pam was describing. It actually begins quite high up here, and then there's even a drop of almost 30 feet. And so in our design, the museum is located to the south of the site, closer towards that intersection, and to be higher up on the hill. And so it's this kind of roof that's almost floating on the hill. And then as you go further down is the landscape design that we've been developing with Reed Hildebrand that allows you to kind of walk around the building as well, in addition to coming from the east side, from campus. So the expression of that form is a little bit of this gently lifting roof that we're hoping feels almost like it's floating above this landscape. And below it is that, and this is also the image from the street that Pam showed, but you can see that below it's hovering over these kind of 5, what we think of as pavilions. And so the art spaces here and here, these 2 different groupings of galleries, but also the teaching gallery, this education wing towards campus, and the auditorium here on the west side, which will serve for screenings and also talks. And so the other thing that you're seeing here is that between these different pavilions are these in-between, these interstitial spaces, the public spaces of the lobby, the cafe, the circulation. And so one way to think about the organization is that we have these spaces that are really technologically purpose-built for their functions. And so the galleries, which have really calibrated lighting for the presentation of work, not only artificial through art track lighting, but also through the introduction of natural light in certain instances to highlight 3D works, or even to kind of produce or present different art viewing experiences. And you see these highlighted in the pink again, these kind of particular pavilions within the space. And then surrounding them is this kind of interstitial space that I was speaking about. And this is where you start to see that mass timber present itself. And so this kind of lightly floating roof is actually the structure itself. And so what you see in the ceiling is not just a finished cladding or a kind of ornamental ceiling, but it's actually it is the literal structure that's supporting the entire building. And so to break it down a little bit, this is mass timber, and so it's an evolution of what is understood as heavy timber construction. And so rather than being full beams that are cut out of a single log, it's actually many small members that have been assembled into a really effectively performing structural beam. And Danny is going to speak about that a bit later. And so that's what you see here. And I think this is the thing that's really quite new, which is that in between these beams are what are called CLT panels, which stands for cross-laminated timber. And so this is a newer technology which allows wood to also be the decking. And so maybe some of you have seen before, like a concrete ceiling deck or a metal deck. This is actually the wood now being used as the deck, and that's quite new. And so we wanted to both utilize that for many of the reasons that Scott was mentioning, lower embodied carbon. This is a much more sustainable approach to construction in that you're not burning carbon to produce steel once, but that this is an actual renewable resource. But also because we wanted to highlight the beauty of this material and what it can contribute to the space. Now, in addition to just being a sort of material that one experiences, we also wanted to have this presence of the wood connect the experience from the interior to the exterior. And so not only would you experience it in the lobby, but also as you're entering the building in these sort of outer porch areas of this outer cafe, the south entry, the space in front of the west entry, which one would be using if you're coming from by vehicle. And then also there's a space here in front of the education lobby. And so this idea that interior and exterior connected, you can see here. So this is sitting in that education lobby, which is right here, and that you can see out into nature. And that this experience that the roof is really present on inside and outside was something that was important to us. And so you can see past the glass, that same structure is the structure of the exterior spaces. Now maybe just a last kind of design point I'll touch on is that another part of the design is that we wanted to produce a few different experiences as you're moving from inside to outside. So this outer area that you're seeing here is at the south of the building, at the south entrance, and the hope was to create something that was welcoming, almost even intimate or domestic in some ways, and how it could become inviting. And so the roof actually comes low to the ground. So at its lowest point in front of the cafe, it's 10 feet off of the ground, and so it provides a space that you can really sit with 3-4 people and have a coffee outside, and also a sort of like welcoming, sheltering entrance, sheltering from sun, from rain, from snow. And then, however, at the same time, we wanted to open up once you enter inside. So the lobby expands into this much taller, grander space that's about 27 feet at its tallest point. And so this height that almost doubles as you get to the interior. So this question of how can we not have a kind of disjointed experience from that exterior space that's welcoming, allows you to sit in small groups, and this kind of grander space that could even host events. I think this is what was really exciting for us because the wood itself has that possibility. So now this is to kind of suddenly change the representation of things. What you're looking at here is actually a mock-up that we did in Quebec with Nordic, the partner that Scott was mentioning. And so this is in their fabrication shop. And what you can see is that we were testing what would happen with this structure of beams and CLT panels if the beams were to actually be rotating in space. So if the beams were to transition from this lower space, this welcoming entrance, to this grander, higher lobby. And what we found is that by nature of wood itself, wood is pliant, wood is flexible, and so it's actually able to transition from these differing heights just by nature of its natural properties, as opposed to something like concrete, which was much more, in comparison, brittle. And so what we were able to get, and this is a photo looking at the mock-up, you can see this sort of sweeping form that you're able to get where you start low, and then it gets really quite tall. And rather than a kind of physical step in a space, like even in the way that there's a step from that portal to this ceiling here, you get this sweep, this gentle sweeping experience in the ceiling, which was very much in line with what we want to produce when I was speaking about this sense of continuity between inside and outside. This is a three-dimensional representation of the timber beams that I was speaking about before. And so you can see them starting low and then kind of sweeping upwards as you get to the center of the lobby. And here's more of a rendering of what that looks like. And so again, you have this sense of this kind of a space that is both continuous between inside and outside, but is also able to transition between these different qualities. And this is just to end on that outer space. And I'll turn it over to Danielle.
Well, first, I just want to give a brief shout out to my team members because I'm still baffled that you guys started your workday at 6 a.m. I know you did, and it's already past 6 and you're still here strong, so kudos to them. And I'm Danielle Gray with Consigli Construction. I'm going to be talking you through how we're constructing the mass timber project. But first, before I dive into that, I want to explain what a construction manager does, right? A lot of people not in this industry typically know what our role entails. So I like to envision, a triangle. Our primary purpose is to ensure that the building gets built on time, on budget, while still meeting design intent. And in the center of that triangle is safety, right? We always want to do all those aspects in a safe manner. You might be, familiar with a project manager, right, who's on the construction management team dealing with budget, material, labor costs. Or you might be familiar with the site superintendent, right, who's, when I used to teach high school students what a construction manager does, I like to compare them to a conductor, leading an orchestra, right? So you have so many trades, hundreds of trades on a job site, and it's a really, busy activity. Hundreds of trades, hundreds of activities working on top of each other. You can imagine that could be pretty chaotic, but the superintendent is making sure, okay, cue in the percussion, bring in the concrete, okay, concrete's done, cue in the flutes, let's go with mass timber. So I always like that vision. So my particular role on the construction team is a unique lens. So I'm a virtual design and construction manager. I see the world through a virtual environment. I basically use graphics to help communicate to the owner, the rest of the team, all project stakeholders, how we're going to build the job. And I also use 3D modeling to spatially problem solve. So now that you know at least what I do, this is a great graphic example of a logistics plan. So Kevin gave some great insight, right? From his slide deck, we knew where the building was located. We also knew the size of the building. And we also conceptually knew that we wanted to build it out of mass timber. So those are key factors in us determining how we're going to pre-plan the job and build it safely. So a logistics plan could show how we're containing the job site, right, with our perimeter fence, It also shows where the trucks are entering, where the trucks are exiting, where the material laydown is going to be, how are we going to sequentially build the mass timber, any police details, right? If there's any pedestrians being impacted around the job site, we want to make sure if we need flaggers with the trucks exiting, entering. You know, again, primary purpose is making sure we're building the job in a safe manner. So first, before we dive into what are the steps in building a mass timber job, let's just look at what is mass timber, right? We're all familiar with the lumber you can buy at Home Depot, the 2x4s, but mass timber is different. It is a large format engineered wood product, and it's really, there's two parts that we're focusing on with this job. The first one is called glue lam, which is glue laminated timber, and to get that, you're literally gluing the pieces together, and that's how we're creating our beams. And then there's CLT, which Kevin mentioned as well, cross-laminated timber, similar to what you do with, you know, stacking Legos. You're layering that section perpendicularly with each other. All right, so what is the first step of building a mass timber job? And really, you want to source and select the material. So we like to, you know, compare the mass timber supplier, in a way is kind of like a car production facility, right? You really want to reserve that time slot with the mass timber well ahead of time. We typically know that, you know, when we're at this stage, we're a year, 2 years out, we need to secure that time slot with the supplier to ensure that when we come time to build, we have the material in place. So how do you start with that? It's right, it's really, if you're going to build a deck in the back of your house, right? Before you hire a contractor, you want to make sure that that contractor, A, has the experience, B, do they have the production capacity, and C, with this job, it's a complex geometry. So we really had to probe through multiple suppliers throughout the country, throughout Europe, to really ensure that they have experience with that complex geometry as well. And then last but not least, do they have the soft skills? We're going to be working with this mass timber supplier through design, through coordination. We really need to make sure that they're going to be pleasurable to work with for the next couple of years. So the next step, and you can notice the length of the arrow drastically lengthens. This is the most complicated part of the pre-planning phase, but probably the most rewarding too. It's the design and coordinate phase. This consistently is going to lower for me. All right, but we'll work with it. So the design and coordinate phase, the end goal is really to get from a conceptual sketch, right, from the structural engineer, from the architect, leading up to what we call in our industry a shop drawing. And a shop drawing is a technical package that you deliver to the fabricator so they have extremely clear instructions on how to fabricate each piece of the puzzle. So how do we decide who's involved with that early design and coordination phase? Well, just looking at this picture as a quick example, we know that mass timber will you know, this picture is kind of the bare bones, the structural component of the building. So we know that the mass timber sits on steel. We also know that at the underside of the mass timber, underside of the glue lam, we have a curtain wall that needs to fasten at the underside of it. And we also have MEPs. I want to highlight MEPs are mechanical, electrical, and plumbing systems that serve the building. We definitely want to coordinate those early in the process because we know they're going to penetrate through the mass timber at certain parts of the building. If we're able to lay those out early, then we can save time and money, but also the quality of the penetration. So how did we design and collaborate together? And that's really where this slide comes to shine because it's a cloud-based software that we used. Once we got the trade partners on board, we basically said, okay, you have your scope, so let's all, you know, model it out, draw it out in great detail in a three-dimensional world. And then as you progress through modeling that out, post it up to a cloud. The merged model is what I facilitated, so we can review every step along the way. At the top right, you'll see an example of the conceptual sketch, and then at the bottom right, that's our end goal, right? Is that technical series of drawings so that the fabricator exactly knows which piece, which angle, which dimension, so they can clearly create it in the shop. This image is a great example of cause and effect. So again, I said it was the longest phase during pre-planning, but it's also the most complicated. So mass timber has a very strict, very rigid set of rules when you want to penetrate or really just coordinate with it. For example, this is a section view through the center of the building. And a section is like, you know, if you were to slice the building in half and then look at it from the side, this is what you get. So we were able to overlay a gutter section detail over that section. And you'll notice that, you know, at the top of the roof, the water wants to shed off, go into the gutter. That water then wants to enter a drain. That drain wants to align with the vertical component of the window. And that vertical component of the window and the whole window on the first floor wants to programmatically align with what the architect has designed. But remember I mentioned the strict rules. That drain wants to penetrate the mass timber. So during coordination, there might be moments where we're too close to the edge, right? And mass timber's like, hold the phone, we can't penetrate this location. So you can really understand the cause and effect where everything is connected. And we really have to look at, okay, do we move the drain? Do we bump out the wall? Will that impact the program? So there's a lot of questions to vet through during this whole process. So after many, many months, we finally get to here. So this is the fabricate and install phase. At the bottom left is an example of our shop drawings. And we finally achieved it, so this is a huge milestone. Shop drawings are approved. We're ready to go. A few quick fun facts. We had over 900 wood-to-wood or wood-to-steel connections. And 40 of those were unique. So you can imagine, right, IKEA, who's done IKEA furniture, right? It's like the set of instructions for IKEA furniture, 40 unique times, 900 wood-to-wood connections. It's amazing. And we had over 500 glue-lam beams and about 300 CLT panels. All right, so items are fabricated. It's being loaded onto the truck. They're revving up, ready to go, bring it to the job site. So what's the next step? We just have to really circle back on our original pre-planning logistics plan, right? And review that with Nordic and Riggs. Riggs is our installer on the job site. And really sit down and understand the sequence of install. But thankfully, what we pre-planned pretty much aligned with our future plan. So you want to start out at the core of the building where the elevator shafts are. And from there, you're simply building up from timber column, and then beams, and then CLT panels on top. And from the core, you're working in a clockwise direction. So this animation is a quick sequence plan of how we're working our way clockwise around the building. It also informs us as a team where strategically we want to place those cranes. And essentially gives a clear picture to everyone being onboarded on site how we're going to erect and install the mass timber. And there we go. Last slide is currently where we stand. So this was taken actually several weeks ago. It's drone footage. So Skanska, our owner's rep, they'll go out every couple weeks and take some drone videos of the job site. So currently, just a couple weeks ago, we finished pouring concrete at the ground floor level. At the south entry, which is to the left here, we'll finish pouring the concrete in a few weeks. And then mass timber will be installed per the sequence. Just last week, our first steel piece got erected, so that's a huge milestone that we're all very proud of. And this video is quite long. We joked that there would be a Mass Timber soundtrack associated with it. But with that, we'll hand it off to Q&A.
So while this plays for another minute, and before Q&A, I just want to take a moment to recognize some of the other project team members in the audience. If you're here with Consigli and Skanska and Williams College, would you stand and give us a wave so we could recognize you? There's a lot of you in the audience. Thank you for being here. And then we also have a really great turnout from the Williams College Museum of Art. If you're with WICMA, would you please stand and give us a wave? Thank you. Thank you for being here. Thank you. And will our panelists please come to the front, and we'll have a bit of a Q&A here. I'll get us started. Let me hand that one to you. So we took questions in advance when people RSVP'd, and we're hopeful that a lot of the advanced questions were answered by the speakers tonight. But I have one that I'll just get us started with, and it kind of combines some of the questions that we received. We are recognizing this incredible museum will be a very significant mass timber project for the Northeast region. And my question is that how do you hope that this project communicates what's possible for architecture in this region? And also, through a national industry context, what are some of the challenges to building mass timber in this region?
I'll take that. I think there are several parts, I think, that are interesting to this question. One is that there's, for our office especially, and I think also for the college, there's an understanding that with building construction plus building operation being together, that something approaching 30–40% of carbon in just, with other items being transportation and chemical production, there's like it's an important kind of industry to think about, and to think about how we can transition to more sustainable approaches to building. So that's one thing. I think what we're really excited about here is that it not be seen as something that, it not only be seen as something that is important, but also that there's a lot of opportunity in it, and it opens up a lot of new ways of expression, a lot of new kind of potential architectural spaces and experiences and ways of producing places for gathering, for learning, that come with that kind of, this new kind of call to build sustainably. So I think we were excited for this, both for those kind of core values, but also because it's an opportunity to see what is possible here. And I think in addition to that is that it's important that we kind of make it almost, to be quite simple about it, like normalize it a little bit, to see that this is very much possible. It is not something that is kind of exceptional, but is something that's very doable. With that, I think in some ways it is exceptional. And so in one way, this building, when it was filed with the building department, actually the Massachusetts Code has only allowed this type of construction with the museum program as of essentially a year ago. October 2024 is when they updated, for all the code nerds, the 10th edition of the Mass Code, which allows for timber construction for a museum assembly occupancy. So that's the one. So I think this, in that way, for this region in particular, I think it is an important and special building. And then I think, the earlier point is just, more spiritually in a way, I think it's really exciting for us to be able to work on this project. And so this was a terrific opportunity for us as an office, and I think, we're really grateful for it.
For any questions in the audience, we're going to pass a mic so that you are picked up on our filming, and it looks like we have one in the back row there.
During the winter months, are you going to have to be doing anything exceptional in terms of timber construction, protection of partially constructed areas, anything that we'll be seeing?
So it depends. Are we getting a blizzard or a light snowfall? We'll have to evaluate the conditions, check the weather reports, and attack that way. If it's a light snowfall, right, thankfully we have limited amount of CLT that it's actually flat on this job. So it's really the flat CLT that we want to, just make sure that there's no standing water. Every panel has what's called a slope shield on it. And so when it gets delivered to the job site, we make sure that slope shield is intact. And it's really, the water can essentially just wick away from it. So it's just like standing water. You just want to make sure that's removed. If it's a blizzard, right, we're all from New England, we know it will happen. You treat it as what kind of blizzard we talk about is it's really the stuff that's just the horizontal plane that you're worried about. Again, anything that stands there, sits there is what you want to protect.
I'll just add. So having our partner up in Canada, where we complain about our winters and ask questions about protection. They do this year round, hundreds of projects a year in much worse conditions, so they continually remind us what true winters might look like and how we're working with certain types of wood that can handle. Although we, as Danielle said, we still take the precautions necessary because at the end of the day we want the best results. So.
So I just had a couple of questions about the materials and the sustainability aspect of the project. So I'm wondering what kind of glue you're using for the lamination process and how you found, and I guess I'll call environmentally friendly glue to serve that purpose. And then you're pouring concrete. I know, I've heard. Are the walls also like a concrete block or concrete? And I'm wondering how the use of all that concrete fits into the sustainability aspect.
Mm-hmm.
So to your point, this new timber technology utilizes a glue to hold all the smaller lamella, which is what they call the smaller elements of wood together to produce this long spanning beam. So this company, Nordic, uses it's a formaldehyde-free glue product, and so there are, I think, within the industry are strict requirements for the types of glues that are used. This one in this particular product is 1% of the mass, and so I think in one sense it is a fundamental part of this technology because it allows us to also not have the need to take down large trees to produce these long span beams. And the other side is to your point that it has these kind of adhesives that hold it together. I think the positive is that this supplier, in addition to some others, are part of a strict number of requirements that have to renew their certifications on a regular basis. And so it is, and that's a number of things. It's FSC certified, forestry stewardship, and we're also with the LDC core, so the International Living Futures Institute. And so I think it's yes, you are correct that there is glue, and we've been kind of selecting our partners to also make sure that we're working with partners who are more experts in this aspect of the fabrication than us, but are kind of understand the importance to us of the overall mission for sustainability. To your point, also there's concrete. The foundation, essentially, in foundations, there's basically not many new technologies that are able to perform below grade in the dirt, basically underground, in the way that concrete does. There are some newer technologies that are coming out of Germany, like a super low cement-based concrete, but these are all kind of still experimental and have not passed the kind of certifications that are required to be used in a building project here yet. I think we're hopeful as an office that those things will become normalized. And similar to the kind of review of our use of all materials on the project under the ILFI, there's also been kind of a vetting of our concrete mixes on this project. So even though it is a kind of necessary evil, it has also gotten scrutiny from our sustainability consultants, Thornton Tomasetti, in helping us select a mixed design, which is all the different ingredients that go into the concrete, that is as responsible as we can be. The walls are, as you point out, a masonry block that's produced in this region. There, I think there's a requirement to be something durable on the exterior that can stand up to weathering. And so it's interesting, at some point we had considered metal or bricks, but I think all kind of having their own particular expression, and we went with this particular masonry for its expression, its durability. It's not concrete. It's a kind of CMU unit, and so it's in the same family, but it's not specifically cast in place concrete, which has its challenges because of the demand of water and having to be produced on site. And so these are actually kind of almost more like block units.
Evan, we are using low carbon concrete at the job.
Thanks, John.
Yes, correct.
Yeah, depends on the benchmark we're looking at, but yeah, it's a for reduced carbon concrete, use fly ash and other things in the mix to reduce the overall carbon footprint.
So I'll just share it so that everyone can hear, is that it's a reduced carbon concrete where we're trying to replace the kind of elements such as fly ash with more sustainable elements and components. I think this has been a more recent development in the concrete industry. So even in the last museum project that our office has worked on, that was not yet available. And so I think what's nice about this project is that those things are becoming more common, even I think across the East Coast. So I think the positive side to that is that these technologies are developing in the right direction, and we'll be able to use them more and more.
Curious as to what the roofing material is.
Yeah, so in some of the question was the roofing material, and so in some of the earlier images from the roundabout, you saw the front of the building. So above the mass timber structure is essentially aluminum shingled roof. This was a really kind of exciting part of the design to us because form aside, like this kind of silhouette of what you're seeing is like, how do you express the form? I think if it were something that were too smooth, it would maybe appear a bit artificial. So we were really interested in this shingle, not only for its the way that each shingle can kind of have a slightly different color, softly reflect light in a slightly different way, and in that kind of move across the roof and express that almost like scales, rather than something that's kind of just like a hard, smooth surface. And the reason also for this material is for its longevity. And so we're working with a great partner who's based out of Kansas City that actually has done a bunch of Frank Gehry buildings in the past. They're renovating the old Air Force chapel by SOM, and so they're very experienced in kind of exterior exposed metals. And so it's been great to work with them. They're able to work at this kind of high end for longevity, durability, and so it's a good material for shedding water, for resisting damage. Yep.
So one more question in the back row.
Thank you. I'm going to go back a little bit to the code that you mentioned because I am a code nerd. And I'm just interested in learning sort of some challenges, if any, that you face trying to bring this building up to code, and especially the knowledge that you yourselves have gone through that might trickle down to other people in the region who might be interested in attempting something mass timber.
Yeah, great question. Also I have to mention our really excellent architect partner. So there's two kind of partner architects on the job. We're SOLID Objectives IDENBURG LIU, we're based out of Brooklyn, and then we're working with Perry Dean Rogers that are based out of Boston. And we're both having worked on this typology of project before. So they've been really excellent in also kind of diving through these questions. To like think about it more broadly, the code is something that I'm sure everybody wants to build their house or your kind of like your shed as quickly as possible, and the code is what makes sure that everyone's building up to a standard, right? So even though it could seem like an obstacle, it's really maintaining a certain standard. How often that code is updated is a much more kind of gradual process. New technologies are not able to be integrated into the code as quickly as maybe you would like. And this is one of those instances where how we can adapt this really exciting and sustainable technology into code that everybody agrees that this is the right way to build is something that is, it's still live, it's still happening. So as I mentioned, this building is only allowed to exist as of the code update last year, even though this has been adopted in other countries or on the West Coast, which is closer to the to kind of different mass timber forests. So in some senses, it's driven economically. But for us, and with Perry Dean Rogers, it was figuring out, to your point, like how do you do this when this is probably maybe the first, if not one of the first kind of museums made of mass timber in Massachusetts. So there are some issues that we had to work through, like how do you fire protect all of it? Maybe that's a question that some of you may have. I think something that's not well known is that timber is actually, when it starts to burn, produces this char insulation layer that actually prevents the center of the timber from burning, and so it actually resists fire more than steel in actuality. But for us, I think this is a funny way where the code has not yet incorporated that. And so for the kind of critical timber columns, they're actually clad in a cement board to make it even more protected. So it's like very, very protected. But that's something that we had to kind of incorporate into the design from early on. Another one was I showed you how the wood is kind of slowly sweeping. That's a very kind of, that's something that we worked on a lot with our structural partners, Fast and Up, and with Nordic, because that's something also that's not as common to kind of use wood to produce this more organic sweeping shape. And so then there was a lot of specific calculations that we had to do in our finite element analysis software to make sure that it works structurally, that it meets the kind of code requirements of structure performance. So there are many, many instances, and I'd be happy to talk about them with you later, to not subject everyone else to these little factoids. But I think to your point, it's not as simple as saying like, oh, we're just going to do this now because it's possible. There are many things that have to be figured out along the way, even together with the town building inspector, who's also helping us make sure that we're doing everything with due diligence.
The gymnasium on Lathan Street, would you classify, which has been taken away, would you classify that as mass timber, and which was a laminated wood beam? And then the second part of the question is, could you describe the end-of-life sequence for the material that you were using?
Yes, so that gymnasium was an early, I'm not sure of the exact date, maybe 60s, 70s, implementation of mass timber. So if everybody is familiar with this building, it was kind of caddy corner from the Williams Inn.
Yep.
So there's a few things that happened there that have been incorporated since then in kind of mass timber building practice. The most important thing is that the connection to the ground was exposed to the weather. And so it received water, it received ice and snow, and that was allowed to kind of enter the grain of the wood and freeze and thaw. Today, no buildings are gonna have that kind of exposed surface. The second thing is that the most susceptible point of a mass timber beam is its end grain. So that's actually, if you imagine like the end of even just like a typical timber beam, that end grain is the one that sucks up the water. And so today what happens, and I can list what we're doing here, is that one is that we're pulling all the end grain away from the roof edge so that it has a natural cover. The second is that we're actually cladding it with a metal cover that is not just flat, it's actually deep. And then third is that we're employing a kind of coating which is called Sanson Wood Force Clear, which is produced by a company that works with this mass timber supplier Nordic, and so they use that manufacturer often to even further coat any exterior wood. And so I think we've discussed this a lot with, because we also have these same questions with different specialists in the field, and I think something that they bring up is like the oldest wood structure is from the 8th century. It's in Nara, Japan, and so wood kind of longevity is really about this kind of planning and maintenance rather than the material itself. And so I think what we're trying to do with the design of the building is make it so that it really is set up to last, maybe not until the 30th century or whatever century. But well into the future. To your question about the end of life, we're actually using a product for the gallery floors, which has been repurposed from old like factory wood beams called Hudson Company. And so what we're doing is using reclaimed wood, which is sawn down from old beams. We're going to use that as our floorboards. So maybe one day, well, this building will never fall, so.
I was just wondering if you did a quick and dirty analysis of how much this style of construction costs compared to standard steel.
Well, this is a great example why I probably should phone a friend, because and also why I wanted to give the lens that I look at through a VDC world, right? We have many experts in our company that deal with the budget. So I'm wondering if there's anyone out in Consigli that did do a cross comparison of mass timber to steel. Because off the top of my head, I do not know. Nope.
Well, I mean, when we think about cost, I think we sort of expand that thinking well into the project and well into the life of the project. And then cost also, we learned a lot through like the last project, Davis Center project, which went through COVID, when steel became less expensive than wood. So we've seen this sort of, the markets constantly fluctuate. So when we start making decisions, we understand sort of order of magnitude on certain decisions, but the sort of unit cost analysis, especially on a project like this, I think it became more about systems and ideas. And so when we think about if this was steel, it would be a completely different project. So it would be difficult to, I mean, we could bend steel and curve steel, and I think that might escalate the cost well beyond this. Whereas I think we found methods and means of sort of establishing the basic concept that was developed into a sort of model of cost around the approach that tied to sustainability, that tied to sort of the general site appearance we wanted. So I think cost, we kind of, there was an established budget, and that's the sort of goals we assigned to our teams, is to sort of bring us a project to meet that target. So I think if we started looking at comparables across there, I think it would have been something that would change the nature of the project in a way. So I think, you know, we probably could have matched costs. I just think it would have been a much different result.
Because we're at the 7 o'clock hour, I would like to talk a little bit about our next steps, our project schedule, and some other programs happening. And then after, please, we're welcome to remain here for a few more minutes, especially if there are any students in the audience who really want to understand, you know, if you have a question about what's going on behind the scenes, come up and ask us. We'll remain here for a little bit longer. But we have here the project schedule, which shows us in the fall of 2025 here with our mass timber superstructure going in. In the fall of 2026, we'll be doing some final site prep and working through landscaping. In the spring of 2027, the interior finishes will be completed. We will be looking for the museum to move into the museum in the summer and fall of 2027 with an opening in 2027. And we intend on having more community forums, so if there are any other topics on your mind that you would like to learn more about, please let me know. And then I want to highlight, there are artist commission talks that are beginning this week on Thursday. Kelly Kashi will be speaking at 6 p.m. and then the following week, Marie Watt and Hugh Hayden a couple of weeks after that, back here in this room at the inn at 6 o'clock. And we have a log lunch planned Pam and I will be speaking at a log lunch. So any students in the audience, please tell your friends to come join us. And we also welcome your feedback. So the QR code will take you to a site where you can share feedback with us or further questions. And we have our project contacts here as well. So I just want to be mindful of the time and anybody who might need to depart. But again, we're also still welcome for more questions. Thank you.